Welcome to the fifth video example for Chemi 330. Today's problem will cover fluid statics. We have an oil tank with an air-filled headspace open to the atmosphere only via a manometer tube filled with mercury. Our goal is to determine the pressure at the level labeled 4 in the figure. Starting with the information that we know, we'll call atmospheric pressure P0, and we know it has a value of 100 kilopascals. We also know the specific gravity of mercury to be 13.57, and this of course is the ratio between the densities of mercury and water. We also have the specific gravity of oil as 0.75, and knowing the density of water to be 1,000 kilograms per meter cubed, we can then determine both the density of mercury and the density of oil. We'll call the height difference in the manometer h with a value of 0.2286 meters, and the height between level 4 and the surface of the oil in the tank h prime with a value of 3.048 meters. Working from our figure, we can see that the pressure at level 1 is equal to atmospheric pressure, or P0. From the levels in the manometer, we can see that the pressure at level 1 is greater than that at level 2. The pressure difference is equal to that caused by the column of mercury between levels 1 and 2, and can therefore be determined as ρgh for that fluid. The figure also shows that pressures at levels 2 and 3 are equal, but the pressure at level 4 is clearly greater than that at level 3. In this case, the pressure difference is due to the column of oil between levels 3 and 4, and can be determined as ρgh prime using density of oil. Working from the right on our figure toward level 4, we can see that the contributing pressures are atmospheric and the pressure between levels 3 and 4, while the pressure between levels 1 and 2 acts in the opposite direction. We substitute in P1 minus P2 and P4 minus P3. We now have an expression with only known values, which we can substitute, and our final result is a pressure at level 4 of 93 kilopascals.